Okay, so in this video we're going to talk about the area moment of inertia. So I just want to make the point that if you were looking at a beam and say this was like a beam of this logo and it went on as a beam, if that makes sense. So for example, if you had the cross section of a circle for a beam, or for an I-beam, if you had something like this, I'm talking about the cross section. It's an I shape, and then the beam goes on like that. Okay, so something like this, but a beam with a cross section of G and T, because why not? Let's just use the Georgia Tech logo. Okay, so with this, I want to use this as an example of the X and Y neutral axes. So for example, if you wanted to find the Y neutral axis, you would look at this area, figure out what that area is and what the centroid is, which maybe it's around here or something. You can look at equations for that. You can look it up in a table. And then you multiply where, we're going to use this as our reference point, but we multiplied the area times wherever that center location is, the centroid. So then you multiply this distance, which is 1, 2, 3, 4, 5 and something, times that area, and you get that component, that contribution. And then you similarly would do that for this, which would be 1, 2, 3, 4 is that Y component multiplied by 2 by 1. So 4 by 2 by 1 is 8, and then so on. And then if you wanted to find where this neutral axis is, you would divide your total area and Y components that you multiplied, which is your Q value, if you wanted to find that neutral axis in the Y direction. It's that Q value divided by the total area, so all of that area added up, divide by that, and you'll find where this neutral axis here is for Y. And similarly, since this is different from an I-beam or a circular beam, you don't have the same, you don't have like a reflection of the shape of the cross section of the beam. And we might be interested, let's say we're interested in taking a look from the x-axis. So the easiest way to do this is to rotate the beam and do the exact same thing that you just did, except now you're going from some reference point in the x direction. And so we might find that our x neutral axis is here, whereas over here it was y. see? So then we end up with the center point somehow. And yeah, I just wanted to show that you would do the exact same thing except in the x direction, and you then obtain the neutral axis in the x direction. Okay, easy enough.